So to basically demonstrate where we started, and because I thought, okay, I'll change whatever's needed, but I didn't need to change anything, or very little. I took some things out that didn't really apply, but so one way or another, this is kind of the architecture and the this is my background, right? So back then, I think I actually gave this for some people that were going to invest way back, right as I left Disney. So it was interesting because a lot of the stuff still applied. So back then, very much highlighted the fact that the real business leverage for valuable blockchain capabilities was too expensive. The success rate, and we even know it more now, was extremely low. Everybody fails when they try to build something on most of the platforms out there.
Right.
It's very risky or dangerous for a lot of different reasons, putting your data out there. I mean, you can look at any of the DAO, you could look at any of the big projects that had real problems because all the data is out there. And so I went in, and this was a very much angle from an architect. So you have danger of data exposure. If you have banking, financial, private information, other sensitive data, if you have business logic that's proprietary, your smart contract is exposed, so that means you can't actually put everything out there.
Let me interrupt you for one second here, because when you were thinking about this, you weren't doing this in a vacuum. You were doing this in a very specific context for the Walt Disney Company. So this was always very much an enterprise play.
Right, and that was this was how we communicated internally. It was like, this is a valuable technology for these reasons. You're talking about media, you're talking about a lot of different, you imagine the things that they deal with, and we knew that we could leverage blockchain, but at the same time, all the platforms were not made for that, right? So we had to describe to them how we could use the technology, but in a safe way, and in a scalable way, and so on. And a big part of it was, in particular with the security, was the comparison to open source. And that is basically that, okay, GNU Linux, right? Beautiful thing. I started using it in the mid-90s, and blew me away, and I never went back, right? Everyone sees the code, right? It's out there. The point is that you want more eyeballs on it. You find mistakes. You find features need to be built, things like that, right? And when you end up with protection of business data, I should go back on on Linux. You're running your own instance. You're doing your own thing, and you have a cooked-in incentive to contribute back or to report bugs or security problems, so that the software can be improved because you're running it. It's an operational thing for you. When you get into open public blockchains, the issue is that your code is out there. So it's running on every single node everywhere.
Right.
Everyone can see it, right? But the problem then is that they're incentivized not to report back. They're incentivized to destroy and grab. I mean, to basically attack what code you have. Even if it's by mistake, even if some of the attacks were supposedly not even intentional, but it's out there. So, and it kills the whole thing. So the model was kind of backwards. So from an architectural point of view, it didn't make sense for real business applications. There are certain
it made
extremely
it much more difficult.
Right, and there's certain things that you want pure decentralized governance and control, which are very limited. That's why Bitcoin is so limited in what it does, because there's fewer chances for mistakes. There's nothing in there that you have to worry about for new code that you're trying to use for your company. one way or another, a lot of where we came from was that traditional software development was already expensive, already had a high failure rate, and that's without any currency or blockchain applied at all. And so when you end up with the fact that you have to deal with economic modeling, with currency, with all these things and skill sets, you end up with, you have to have software development, you have to have security background, you have to have scalable systems, crypto, distributed computing, blockchain itself, and then economics and game theory. And you imagine if you're going in trying to build a system and you're needing an upgrade or you're needing a new feature, this is not going to attract you. This would kill your ability
For
to
most
actually
enterprises,
succeed.
sure.
Right. So we abstract. And this is basically explaining why Dragonchain is the way it is. That we abstracted the blockchain components. We looked at it at a high level and said, okay, there's a proof component, there's a consensus component, there's smart contract components, there are currency and tokenization. Right. To apply a business focus, we came up with what we call context-based verification, where you have multiple other independent chains verifying your blocks from different contexts. So, and that was the whole thing. We have a, well, I'll get into it. Yeah. These were the goals, and these have remained on the website forever. Fast blocks, ease of integration, simple architecture. Protection of business data was probably the primary one, especially inside of an enterprise. That was the most important thing, and it's not it's a structural protection. It's a separation of them.
And we'll unpack that a little bit more
Right.
later, especially as we talk about that in smart contracts, because
Right.
those are the huge
Right.
differentiators.
So here is representation of a simple standard blockchain. That is, no matter how many nodes are on it, here's a block which has a hash of the prior block up until now. And you basically move time to the right, and every block has a hash of the prior block. Simple stuff. What we did was we took the business level. So every single business node has its own blockchain, and the payloads in the transactions are arbitrary. So they can be anything they want, including large data sets, because that business node knows its own data storage requirements and everything else. And the real reason it doesn't matter is because before the block is sent out for consensus for verification, the payloads are stripped, because our verification consensus does not require any knowledge of the business data, right? The level 2 nodes that are independent and out there aren't going to understand your smart contracts and your data. They don't care about it. What they care about is everything signed? Are the network rules followed? So on and so on. Are they paying for it? Right.
And as we go through examples over the next 24 hours, you're going to see how that hashing works. And today, for this live demo, everything's being written to an S3 bucket. It could be done on Microsoft Azure, it could be done on Google, AliCloud, or if you wanted to run it inside the four walls of your own data center, or you had your own hybrid cloud structure, you could hash the data and put it there, and it does that by default in Dragonchain. I still think one of the best features we have is the way our Block Explorer works, and we show Eternal later. That is the sexiest thing, because you're actually able to see the data in context, from a business level, and from a technical level.
Right. And so we can go through real quick here. The second level is validation. So it just checks every transaction to make sure that it's sound. The level 3 is a network diversity, and this really came out of the fact that at Disney we had multiple business units, and so back then, the entire thing was intended to be in-house, and so the level 3s were to make certain that a business is not validating its own stuff, right? That we want it to be across the entire enterprise, and in this case, currently it's across the world that it checks. Do I have 3 level 2s that are independent? the level 4 notary is an independent entity identified so that if you're looking at the proof report, if you're looking at the data, you can say, I know that so-and-so signed it, and it's a real entity, it's a real org, it's, something.
Accounting firm, a law firm, you can get validators, you can get really large companies.
Yeah, and it literally is signing a hash of the level 3. And the last one is a public bridge, and at Disney we did Bitcoin. When we first came out and launched Dragonchain itself, we started with Ethereum, and currently we have Bitcoin, Ethereum Classic, and Binance. We did have Neo for a while, but they had an update that didn't work, so it's dormant. We hope to go back to it at some point. But the interesting thing is that every time you get a level 4 for one of your business blocks, that level 4 is broadcast to randomly one of those level 5s. And over time, your next block would likely go to a different level 5. So let's say you get Bitcoin the first block, the next block you get Ethereum, the next block you get Ethereum Classic. That the level 1s are tied together, so you're aggregating the network security, the proof, whether it's hash or whether it's stake or other proofs of those level 5s. So every single business transaction that you put on Dragonchain ends up provable to Bitcoin, Ethereum Classic, and Neo.
So we've been interoperable for over 2 years, and there are literally thousands, tens of thousands at this point with the tests we've been running, and we'll see in production today more with all of those networks. And Dragonchain's first chain really to do that. And tomorrow morning we'll have Jonathan Olson from Aon Law here talking about the patents themselves. Normally it's pretty dry stuff, but I think it's really fascinating the interoperability that was built in from day one for Dragonchain.
Right, it's a really interesting implementation too, so
Yeah.
we'll probably get into that on how we do it, because it kind of opened up some eyes about what's possible in interop. And one point here that is interesting, and it's a little bit abstract, but if you're looking at this this slide here, that the lower on this slide things are, the simpler, the lower security, and the more trust is applied. That is, if it's your own business node, you trust it. If it's a business node of another business unit in your company or a partner or something, there's some level of trust. I trust their data because I have to trust their data, or my own data. As it moves up, you have the ability to prove to others that might be consuming that data, or that you might have to prove that something really happened. The higher in this chart that your block goes, and the further to the right that it goes, the more hash power of Bitcoin and the more hash power of Ethereum is applied, so that you have a level of proof. So let's say you had a transaction that happened 8 months ago, that you're likely going to have dozens of level 4 notaries. So basically every single entity will have signed your chain at some point with the proof that happened in the past. And the same thing for all of the public networks. So if you had, if you took it to court, you have both the angle that I can show real entities if you don't understand Bitcoin and don't understand what hash power is. But on the other hand, something that wasn't possible before Bitcoin and blockchain tech was that you can actually measure to someone, here's about how many dollars it would take for me to fake this data. So you can pretty well be sure that I'm not faking it. So anyway, that's really interesting. And I basically, this is how they go out. Basically, the business node keeps pushing forward, sends to 3. In this case, right now, everything's configured for 3 L2s, and then up to L3s, L4s, and then L5s, and then they just continue to the right. Every single one of these chains is independent. It is its own blockchain. And something that is very hard to illustrate, that this does not show, is that your business node is not going to the same 3 L2s every time. It's not going to the same L3 or the same L4 or the same L5. So it's a it's a lot more three-dimensional.
It's extremely secure,
Right.
and it makes it very robust and much harder for a 51% attack or any kind of attack. And because you can change the validation rules.
Yeah. And you can add your own. It was in
Yeah.
the architecture itself. We knew that these were the ones that we came up with inside and Disney, but that we know, and we've come up with some recent that can operate at a little less formally than this,
Yeah.
where you have your own verification and your own additions to the consensus algorithm. So you can pretty much do anything you want with it, but it's interesting back then. Trust and trustless. We had some angles on best practices DevOps that when we spoke with some pretty big enterprises about a lot of things, and those were their biggest concerns, especially this is blockchain. What about DevOps? And everything, because it's hybrid and because you're running your own business nodes, follows best practices that your staff already knows. So it's really nice.
So maybe talk about that a little bit, because it's a blockchain as a service, and we're able to deliver pretty rapidly and spin up pretty rapidly, which is different.
Right. I don't know the current spin-up times. I know they're fast. They're faster than anything else because it's Kubernetes and Docker-based.
Right.
And that lends. We'll have a lot more about that later, but there's some tremendous power with that.
Yeah, I mean, when we do console, people will be able to see you can actually start up your blockchain for an enterprise or an individual in less than 10 minutes.
Oh, yeah.
And be up and running. And we show you how you can implement smart contracts using any code base. The power starts to really become evident.
Right. And here's another angle that a lot of people, especially back then, well, what about the competition out there? And you think even Microsoft, well, actually, they call it something else now, right?
Yeah.
But our angle was not, okay, Bitcoin is obviously the king. It still is, right? Currency and fintech, massive hash power. It's the largest computing concern on Earth, right?
Yep.
Orders of magnitude above anything else. We don't really consider it a competitive project, right? I mean, we want to leverage that. So we use the hash power for trustless security primarily, but our interchain lets you use Bitcoin for whatever you would need to build on Bitcoin in a way that you can still interop with other things. Ethereum, same thing, Turing complete, accelerating adoption, even back then. I don't know the numbers now, right? And we're using it for security. Obviously, we're using it for. Back then, we did not have a token, right? So
Yeah.
we are using it for what we call wormholes, but it's basically token security. So our token that is used on our hybrid chain is based and proven on Ethereum, right? It's basically Ethereum's killer app, right? Hyperledger, private only. So. We worked with them early on to talk to them, and there are a lot of things. We have an unproductized interchain with Hyperledger already. It's doable. It's just code. Anything you can do with code, it's doable. So, and Microsoft, and we have run nodes in Azure and Google Cloud, and of course on-prem. And on Raspberry Pi. So this is the project state back then. We had 3,000 lines of code, 27 files, a lot to do, much to do,
Yep.
right? So anyway, it is interesting. That's why I kept this. And the funny thing is, we're back on Slack now, so I haven't changed this. Probably the glossary is not there anymore, I'm sure. I think that was from, I don't even know where that was hosted, but either way, it was interesting. So.